In this video, we will be discussing the Teledyne high dispersion inductively coupled plasma optical emission spectrometer. To begin, I will be introducing the different features of this instrument that you will be using during this lab. The first thing we'll be using is a nitric acid rinse solution that is used to rinse all the tubing up to the ICP torch. The next thing we will be using is a water cooler that's used to cool the coil that generates and sustains the inductively coupled plasma. The next feature we have available is the Lehman Labs auto sampler, which will allow you to introduce the variety of samples you will be using into the ICP torch. The next thing of note is the peristaltic pump that we will be using. This is used to introduce the nitric acid rinse solution into the Lehman Labs auto sampler. It will also be used to draw up your sample and introduce it into the plasma torch. So once the sample chamber door is open, we have the concentric nebulizer as well as the cyclonic spray chamber. This allows us to introduce our sample into the gas phase. If we then open the ICP torch door, we can see the ICP torch itself with its fused silica. We can also see the coil that sustains the inductively coupled plasma. This instrument also has two views for the ICP torch itself. We have the radial view, which is coming directly at us from the torch, and we also have the axial view, which is going directly out of the torch into the instrument. Before starting the ICP torch, you need to be sure that you turned on the argon tank. To do this, rotate the valve counterclockwise very slowly until the pressure begins to rise. At this point, you can open the tank all the way. When you do this, please be sure that the argon line pressure is between 90 and 95 psi. Now that we have reviewed the basic features of the ICP atomic emission spectrometer, we can now go into the SALSA software that controls the instrument. So here, the SALSA icon, we'll double click on that to open the program. This will now initialize the instrument, allowing us to begin the experiment. What we will begin with is general operating procedures for this instrument using the SALSA software. What I will go through is a general positioning of the plasma and also generally aligning the wavelength that we'll be using for our sample. The first thing we need to do before starting the instrument is to check the interlocks, which is this icon here. Here we see that everything is green except for the air knife and the argon high. So what I have already done is I have turned on the argon tank and the water chiller, which we need to do before starting the instrument. I have also allowed the instrument to purge with nitrogen for at least 1 hour before starting the SALSA software. Now with only the argon high, once the argon flow starts, this will then be at the correct pressure, and the air knife will actually start once we ignite the plasma. Now that we have checked the interlocks, we can then click Auto Start, which will begin the plasma initiation. Here it asks if we have checked the interlocks, which we already have done, so we can click Yes. Now that the plasma has been ignited, we can see the ICP here lists plasma as the plasma is ignited. Once the plasma is ignited, please wait 10 to 15 minutes in order for the temperature in the torch chamber to stabilize. So now that the plasma has stabilized, what we can begin to do is select the elements that we want to measure with the ICP. So what I have prepared already and put in the Lehman Labs auto sampler is a 10 ppm copper ICP standard. So what I will do is I will navigate to the element selection. I will select copper, which will allow us to select the different copper wavelengths that we would like to measure. Here I will select the 324 nanometer copper line. In order to do this, I will highlight that copper line and click Add Line. We can now see that this copper line has been highlighted in the element selection. What we then need to do is to select the torch view that we would like to use. Here I would like to use the axial view for this experiment. Now that we have selected the element we want to use, I will navigate back to Instrument Control. Here I can now take the Lehman Labs auto sampler and place it in the cup with the copper standard by clicking Cup. Now that the auto sampler tip is in the cup with the copper standard, I then can go ahead and position the plasma for this compound. Here, when I select position plasma, we have the option to select which line we would like to look at. And here, since we've only selected the copper element, we will select that line. After doing this, we can then hit peak plasma. Now that the source has been positioned, you can click close on this screen. The next thing we will need to do is to align the wavelength on the detector with the sample that we are using. So again, we need to make sure that the auto sampler is in the position of your copper standard. We will then go to the top here and click the auto align button. The first thing we need to do when auto aligning is to check the mercury reference line. Once this line has been checked, we can click auto align. Now that the mercury reference line has been auto aligned, we can highlight that mercury reference to see if it has been auto aligned. After it has, we can click accept. Now that we have accepted that mercury reference, we can select which wavelength we would like to align next by putting a check in the box and then clicking auto align. Now that the instrument has finished auto aligning to our copper wavelength, we can highlight it and make sure that these crosshairs are on the brightest spot of that detector. Now that we accept this alignment, we can put a check mark in the box and click accept and close out of the auto alignment. Now that we have both positioned the plasma as well as auto aligned to the wavelength that we would like to measure, we can now go ahead and enter standards into the standards/MSA icon. Here we have the options to add standards, where here I will name the standard test 1 and put in a concentration of 10 parts per million. After entering the data, we can select OK. This will now allow us to select which line we would like to measure for this standard. When measuring multiple elements at one time, you may select all elements or a single element that you are measuring for each standard. Once your standard has been put into the standard/MSA, we can go back to instrument control. This will allow us to again move the Lehman Labs auto sampler to the cup that we are measuring. And after this, we can then go up to the top bar and click standard. This will bring up the standard IDs of each standard we entered into the standard/MSA icon. Here we can select those standards. Since we only have one entered, I will select test 1. We will leave the 25-second uptake to allow the sample to reach the torch. And after this, we can click OK. Now that the standard has been acquired, we can move in the bottom left tab where it says Analysis. This will then have our test sample with a corresponding symbol, wavelength, and light intensity. Here, you would be able to repeat this process for any concentration standard that you might want to measure. Now that we have acquired the samples that we want, the last thing we need to do is to be able to export this data for further processing. In order to do this, in the Analysis tab, move to the Report page. Here you can select what you would like to export. Here I will export the sample ID, the wavelength, the view, and the raw intensity of the acquired data. When these are selected, we can then go to the left bar and put a check mark in each box that we want to export for each sample. Here, click on Format 1 in order to generate that data. This data can then be saved as a CSV file to the hard drive of this computer.